Strength of hollow shaft. Consider a hollow shaft, inner radius R2, outer radius R1. In this, we consider sectional area, we consider dx on elemental strip thickness is dx. So consider a hollow shaft subjected to torque T. Consider a hollow shaft subjected to torque T. Let R1, R2 the outside and inside radius of the hollow shaft. Let us consider an elemental area dA at distance x. Let us consider the elemental area dA from distance x from the center of the shaft, and thickness is dx. So this whole area is dA and the thickness is dx, and from center distance to dx is x. Area of elemental strip dA equal to, so this is considered as a circular area, so 2 pi r into dx. 2 pi r into dx is the elemental area of this one. And then shear stress at this section. So whole shear stress acted upon this area is Fx equal to Fs into x divided by r1. X divided by r1. This is the stress acted on this area. So turning force equal to stress into area. Force equal to stress into area. Let us, the area is stress is Fs into x into r1. The area is 2 pi x into dx. So stress into area. So finally we got Fs into r1 into 2 pi x square into dx. X multiplied with the x and the x square dx. Fs by r1 equal 2 pi x square into dx. So turning moment, torque of this element. So we want to find turning moment torque of this element dt equal to shear force into distance of elemental from the axis. So what is mean by torque? Force into perpendicular distance. So here dt equal to shear force into distance of element from the axis. So consider 2 pi, so shear stress equal to 2 pi divided by r1 into fs into x square into dx into x. So distance from the center axis is equal to x. Distance from the center axis is equal to x. So we consider 2 pi r1 into fs into x square into dx into x. This is the distance from the center. So finally 2 pi r1 divided into fs x cubed into dx. Total torque that can be found by integrating the above equation between r1 and r2. So just we calculate the total torque by the integration. The limits are r1 and r2. So here the function is x cubed. Here the function is x cubed. So total torque equal to integration from r2 to r1, 2 pi into fs divided by r1 into x cubed into dx. That is equal to, so here these are all the constant, so we put outside 2 pi fs divided by r1. So function is x cubed, x power n, integrating the x power n plus 1 divided by n plus 1 as the formula of integration. So here our answer is 2 pi fs r1 is constant, we put outside, and the function is x power 4 divided by 4, the limits from r2 to r1. So here just we take away the constant and applying the limit r1 power 4 minus r2 power 4, we got 2 pi fs r d1 by, because r1 equal to d1 by radius is the diameter divided by 2. So put all the radius in terms of diameter, we got d1 by 2 power 4 minus d2 by 2 whole power 4 divided by 4. So finally we got 4 pi fs divided by d1 into d1 power 4 minus d2 power 4 divided by 4 into 16. We got torque equal to 5 into fs divided by 16 d1 power 4 minus d2 power 4 divided by d1.